Hello everyone, I'm Chong-San Hong. Today Professor Deqi Liu and I will talk about our research development on the 3D printing of ultra-high performance concrete. I will focus on the introduction of this novel concrete material, and Professor Liu will focus on the 3D printing. I'm the director of the Laboratory for Advanced Concrete Materials and Structures at the National Cheng Kung University. The goal of our laboratory is to develop durable and sustainable concrete materials. The reason we are doing this is because conventional concrete materials have some issues, for example, durability, mechanical properties, and workability. So if we are able to resolve these issues, which means that we will be able to reduce the dimensions of concrete materials and help improve the sustainability of our environment. A unique property of ultra-high performance concrete is that it has a very high compressive strength. Conventional concrete materials usually have a compressive strength around 30 megapascal. UHPC has a compressive strength that is more than 5 times higher than that of the conventional concrete material. Resistivity is an indication of the durability of concrete materials. UHPC's resistivity is 10 times higher than that of conventional concrete materials. Conventional concrete material is brittle and has no warning before failure. On the other hand, UHPC not only takes a higher external load, but also shows a greater deformation capability, which allows such a material to absorb a significant amount of energy when subjected to external loads. When our skin gets a paper cut, our skin can self-heal itself. Similar to our skin, UHPC has the self-healing ability, which allows it to self-heal its crack. In order to facilitate the use of UHPC in engineering practice, we have developed multiple novel construction methods. For example, we developed UHPC shotcrete, UHPC precast panels. So these new construction methods allow a faster and easier construction process without the need of formwork. Earthquakes can cause structural collapse and significant cracks and damage to structural walls and masonry walls. So we try to apply a very thin layer of UHPC on the masonry wall, and the experimental result shows that the strength and the deformation capacity of the wall can be enhanced by more than 2 times. We also attach the developed UHPC precast panels onto reinforced concrete columns. And the test results show that the strength and the deformation capacity of the column can be enhanced by more than 2 times. And later on, Professor Liu will talk about our development on the 3D printing of ultra-high performance concrete.
I'm Deqi Liu from National Cheng Kung University. Our team is from Anhai with Dr. Zihao Chen and Dr. Youwei Chen. And this team together to set up the multi-axis 3D printing system. The multi-axis 3D printing system has been developed and performed by following steps. The first step is the modeling the structural CAD, and the second step is to slice it as the CAD data. After that, we develop the numerical simulation method to predict the structural performance. And after that, we adjust the robot arm parameter and execute the printing. The numerical simulation model we use to simulate the 3D printing is a novel method called infinite element method. This method only needs the boundary nodes only. So the 3D model with the slice data and the boundary node, we can perform the fast simulation. The experimental work are also needed to do the simulation. Especially the Young's modulus, we need to use the experimental to get it change with time. The multi-axis 3D printing system, it looks like this slide. The left-hand side is the robot arm. The right-hand side is the feeding system. With this system, we can construct many different layer configurations with vertical only, or inclined, or with cantilever. This slide shows two types of the construction method. The top one is the vertical layer with cantilever type. And the bottom one is an inclined layer structure. And we can see both construction methods can use our robot arm system perform well. And now we're showing a 10 seconds demo film to see the performance of the system. It's the end of the talk.